Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The rigid bar is supported by a pin at A and two steel wires, each having a diameter of 4 mm. If the yield stress for the wires is 530 megapascals and modulus of elasticity E is 200 gigapascals, letter A determine the intensity of the distributed load W that can be placed on the beam and will just cause wire EB to yield. What is the displacement of point G for this case? Also determine the intensity of the load W that will cause only one of the wires to yield. Assume that the steel is elastic, perfectly plastic. So meaning to say the steel can go back to its original shape and size. For this elastic material, and perfectly plastic means when the steel yields, then everything will yield also. So take note that in the first part, only EB will start to yield here because CD is far from the pivot point, so it has greater displacement. So if EB starts to yield, much more with CD. So CD has yielded actually. So the stress in AB is sigma y, the stress in CD is also sigma y. By principle, they have the same stress of sigma y because when the steel yields, remember in the stress strain diagram, the portion is almost flat, that uh, the stress is almost the same, is the same. So this is sigma y area, this is also sigma y times area. Then we have W of length 0.8, zero point 0.4 plus 0.25 plus 0.15 meter, that's 0.8 meter. So we have reactions at A, horizontal reaction is 0. So summation moment A 0, counterclockwise positive equals clockwise. So sigma y times A times zero point 0.4 meter plus sigma y area times 0.65, then equals W times 0.8 times 0.4. So zero point 0.4 plus 0.65 is 1.05 sigma y area. So 1.05 times 530 area is pi 2 square. To convert that to newtons equals 0.32 W. So W in newtons per meter is equal to 21,854 newtons per meter. For part B, what is the displacement of point G? So let's have the exaggerated deflected shape of this neutral axis of the beam. So this is delta B, this is delta G. Then from the figure, by similar triangles, delta B as to 400 mm equals delta G as to 800 mm. Therefore, delta G is 2 times delta B. Since formula for deflection is force length over AE, or stress length over E, so delta B is stress in B, which is sigma y, length, which is 800 mm, over E, which is 200,000 megapascals. So delta B is stress in B, which is sigma y. It yields length of BE over E. Therefore, delta G is times 2 of that. So 2 times sigma y 530, 800 mm over 200,000 megapascals. So delta G can now be computed in mm. Delta G is 4.240 mm. Then Also determine the intensity of the load W that will cause only one of the wires to yield. So if only one of the wires will yield, then the possibility is CD will yield because it has greater expected displacement than B. So let's call that delta C, and let's replace this as sigma B area. B will not yield because only CD will yield sigma YA, and it has lesser stress. So letter C, call this delta C. Delta B as 400 equals delta C as 650. So that means delta B is 8/13 of delta C, where delta C is stress in CD, which is it yields 530, area which is pi 2 square over E. So delta P is stress in B, LBE over E equals 8/13, 530 length in CD over E. So since length of BE is equal to length in CD, we can cancel that. E is also common, we can cancel that. So delta B can now be computed 8/13 of 530. So stress in B is 8/13 of 530. So the stress in B is 326.15 megapascals. Then we sum up moment about A. So 326.15 times pi 2 square, so that's the force in newtons, times 0.4, plus 530 times pi 2 square for CD times 0.65 equals W times 0.8 times 0.4, just like this. So we can now solve for the uniform load W. W is equal to 18,652 newtons per meter. So that's it for this problem.